Hey, what's up? I'm Jason, and today we're going to talk about collections. I think this is a really important subject that a lot of people don't learn about early enough in their careers, and they start off with a single collection or a set of collections that they use, and they don't even know that that's what they're doing. So if you're used to just using arrays all of the time, or maybe you use lists all of the time, and that's pretty much it, this video should be very helpful for you. If you're using all of the collections that you see up on my screen right now, well, hopefully this is still helpful because I'm going to cover a couple real world examples, or at least close to real world examples that show some ways that you can use these other collections in kind of cool and interesting ways. Anyway, if you're interested in this kind of topic, please, don't hit like, don't hit subscribe, just share the video, hit share, put it up on Facebook, send it out to all your friends, email it to your mom and tell her to share it too, or hit like and subscribe. But really, if you can share it, that's the best thing. I really appreciate it. Also, everybody on Patreon and on my email list, I really appreciate you guys. Thanks a lot. All right, let's get going. So the first type that I talked about was an array. So I just want to briefly cover what an array is, show a real quick example of an array in a kind of boring example right here with a random particle player. So I've got this class here that's a mono behavior, so it's a component. I can drop it up in the inspector, and it has an array of particle systems that I marked public, even though I put an underscore there. So really this should probably be like private and a serialized field just to match my common naming standards of underscores being private. There we go. All fixed up. Now we've got an array of possible particle systems. And this would be like a set of child particles on this object maybe that I've assigned to it. And then I've got a play random particle method that takes a position. On line 9, we pick a random index from 0 to however many particles are in that array. And then on 11, we move it to the right position, and 12, we tell it to play. Nothing special, but a very simple example of how we would use an array. Now, we can't really easily grow this array or add particles to it at runtime. We could, but it's not simple. And we wouldn't want to use arrays for everything. So the next thing that people usually find, and the one that we're going to cover next, is the list. And that's on Enemy Manager right here. And this is really the next one that I found as a C# developer too. So as I go over this, I'm kind of hitting them in the list or in the order that I learned them in, right? It's kind of like a sorted list, which I won't talk about today, but it does exist. I also just don't really use them. That's why I wasn't going to talk about them. So let's look at our enemy manager. Our enemy manager is a mono behavior. And before we dive into the list specific stuff, which is all down here, the little bit of junk up here is just to make it a singleton. And this is just because I've got a little demo that I want to show and I need to be able to reference this thing. So we've made a singleton by making a public static enemy manager property named instance, and then in awake we set the instance to this thing. If you haven't seen this before, this is an expression body method, and it's something that I use that it basically replaces the little brackets on the beginning and the end there, but it shortens it up if I just do a little one-liner for a method, and that's kind of the only time that I do it, if it's something small like this. So let's go on to lists, like I said we were going to talk about. Line 10, we have a private list of enemy. So the brackets there means that that's the type that our list contains. And we have enemies right there, like enemy right between me, right between my fingers. So a list of enemies, right? And we instantiate it right here, so it's not null. We always have to, with our collections, new them up, instantiate them somewhere. Right? We have to give them something, otherwise it'll be dead, or a no reference exception. If we did something like this, go, oh no, when we try to add an enemy, it's gonna blow up. So we have to make sure that we instantiate it somewhere. So then we have an add enemy method, which just adds the enemy to the list. Very, very common thing, right? Everybody here, hopefully, probably has added things to a list. You can also loop over the list. You can remove things from the list. So we can have a remove enemy with a public void remove enemy, just like this. So enemy, and we can even make this an expression body method and just say enemies.remove enemy. And it's not even going to blow up. It'll be fine. Even if the enemy is not there, the list is going to say, hey, don't care, no problem. I did whatever, it wasn't there, it's removed, you're fine. So there we go. We can add, remove, we can loop over these things. We can even kind of find things in the list, but finding things in a list is not the fastest. So if the list is small, doesn't matter at all, right? Like if you got a list of 10 things, 100 things, and you want to find one of them based on some property, you can loop over those and find it really quick. You can use a link statement, find them really quick. When it gets to be a much, much bigger size, though, things start to fall apart. And we're going to talk about that and a solution to that in just a moment. But first, let's go back to my notes. So let's see, my notes were in the random particle player, and we're going to look at the hash set next, which is in the spammy trigger. So remember how I said in the enemy manager that this is not unique. We could technically add the enemy 2, 3, 4, 5, 6 times. There's nothing that would stop us from adding that same enemy to the list over and over. A hash set, however, will. So let's take a look at our hash set in the spammy trigger class. So our spammy trigger, because just wanted to come up with something really annoying and simple, right, is a trigger that spams whatever is in it with debug log messages. It could be something in a real world case that maybe heals everybody around them, gives them a buff that they get when they come in and they lose when they leave, or does some damage or pulls everybody in, whatever it is. Maybe it's like sucking them in towards it. Whatever the thing is, it's just a trigger that does something to everybody that's inside it. And how we're keeping track of everybody that's inside it is with this hash set. So on line 6 here, I've got a hash set of enemies. And the hash set, like I said, works a lot like a list, except that it will keep the items unique. And the details of how that works, I don't want to cover today. You're welcome to look into it. I recommend it. It's actually pretty interesting. But what you really need to know is that if you add things to a hash set and they're already there, it will not add them again. And here's my example of that right here on line 11. So say line 10, we get an enemy that entered our trigger. And then we say enemies.add our enemy on line 11, but we get back a return value, a bool for just true or false, whether or not we added the enemy. So if we did add it, I say, hey, we added them. Otherwise, I say, hey, it was already in this list of stuff. And why is my brackets a little bit weird there? Let's fix that up. Anyway, I think you can kind of see the value here already. We don't have to do a check to see if the thing's in this enemies collection. We know that it's not there and it's not going to get added again. We also don't have to worry about some other chunk of code adding things to it. So you might think like, hey, I don't need to do this. I could just check with the other list in the other thing. Like just like the entity manager or the enemy manager, right? I could just do a check and say like, hey, if enemies.contains enemy return. And yeah, I could do that. It would work. It's not quite as fast, but it also has the downside of, when Bob or Joe come over here and they go public void add 2 enemies, and then they take in 2 enemies and they add them both. I'm not even going to type it out, but I hope you get the idea that somebody else could come in here, add a new method, add things to this list, and the list is no longer safe. If it's a hash set, it's always safe. I don't have to worry about it. I don't need to write this extra code. Everything's good. So that's just one good example of a hash set. I use them for a lot of other things. If I want to take in data from a bunch of sets or sources and just kind of make sure that everything is unique, I can do that. Just dump them all into a hash set or add them all into a hash set. But a lot of the time, it's just when I want to keep things unique and I want to make sure that things don't get added twice. And that's usually what I use it for. That was the use case there. So let's jump over to the next one. And the next one is the dictionary. So I talked about slowness and the slowness that you're going to get from searching a giant list versus a small list. Right? A small list doesn't matter. It's generally fast, right? Unless you're doing it all the time. But a big list that you're searching all the time will be extremely small, or not small, slow. It'll be extremely slow. So let's take a look at this. Let's take a look at a dictionary and how we can use that, in one way to speed this up. And then we'll dive into a couple other dictionary examples because really dictionaries are probably the coolest data type that you'll see today. So let's look at the item repository. Item repository here is just a static class with a static dictionary of type int, item, and it's named items. It's not initialized, notice that. And let's talk about what this means. The first thing here is the key. So a dictionary is kind of like it's a key value pair or a way to look things up fast. So we have a dictionary of integers as the key, so we'll have a number for our key, and items as the values. So when we add things to this, we'll be adding them with a number that's some sort of an ID or some identifier, and then the actual item. And then what happens is we can look at things up by that item ID or the ID, whatever the key is that we have, and we can do it really, really quickly. We can also verify that things are unique because we can only have one of each key in there. They have to be unique. It's kind of like a hash set for our keys. So we can do the lookup really fast, and then we can find the related item very fast too. So it's a really good way to speed up lookups of large sets of data. And in this case, we've got this public static method called load items, and it grabs a list of items from some remote web service or database, right? Like some other thing that's got a bunch of data that we're pulling down. In my case, this could be like 100,000 items coming from some memory cache or a database or some web service or something, right? And we want to be able to look these items up instantly on a server. This could also be pulling in from some local files or some serialized data or some scriptable objects or something like that. It could be anything that you want to be able to look something up quickly in. So we're getting this list of items, and let's take a real quick peek at the item. Item, it has an ID, a name, a value, and an item type. Kept it really simple. This could be huge. It could have all kinds of properties on it. So we've got this list of items, and right here, this is kind of the cool part, the thing that I wanted to show in here the most, which is on line 18, we can actually use the link extensions to generate a dictionary from our list with a key value from our properties. So as long as the IDs of our items are unique, this will work fine. If our IDs are not unique, this will blow up. We'll get an exception saying that it can't add the thing twice as the key. But as long as our IDs are unique, which in this case they are, we can actually create a dictionary by using this syntax right here. And the way the syntax works, let's just kind of split it out into multiple lines. The first thing that we have to do is give it the lambda statement for our key. And usually I just have this as K, and I just make this be K. So what happens is it's figuring out what the key should be and putting it into here. So it's whatever this ID is. And then the same for value. I usually do V and V. Value, it doesn't matter. It's just like any other link statement or lambda that you've done before. If you're used to them, you should be really familiar. If you're not, I don't think I can dive into that right now. But using this syntax, the to dictionary with the key and then the property right there and then the value just allows you to build up a dictionary that's very easy to search and very fast to search. So then I can just call a get on an item and get back that item from anywhere. The other nice thing about this is if I want to be able to hot reload my data, I can just replace the items or replace the data in these items and then constantly read into it. Anyway, a lot of cool use cases for this stuff. Most of the time, though, it's just kind of done on awake, and it's parsing some scriptable data or some other data and just shoving it into a dictionary so we can access it quickly. Now let's go on to another dictionary setup that also uses a queue and actually talks about a real, full, fun inventory system. Well, a real, full, not so full, partially full, but still fun inventory system. Here we go. We've got an inventory system, and let's take a look at the top. We actually have a stack. Oh, wait a minute. Nope. We're going to do a selection counter first. I lied to you. Before we hit the inventory system, let's look at the selection counter, because I said I wanted to jump into the Unity project, and I want to do that. The selection counter is going to allow me to really do that. So let's take a peek here. We have a selection counter, and here we've got the dictionary reversed. So I've got an enemy for the key and an integer for the value. So notice I'm not just using a number for my lookup. It's not just an ID lookup. I can also just use any old object. So I'm using my enemies here. And I've got, this is that same singleton pattern stuff. So just ignore this. This is the same singleton, so I can find this in the code. Now I've got a select method here, and let's see, what I really care about, let's go to the update. Ignore everything else for now. Let's start an update, because that's really where we want to go. So in our update, we check to see if we left-clicked with get mouse button down. If we did, we generate array based on where we click. Yep, don't use camera.main. I know, just an example. Then Then we get the ray here, and we do a ray cast, and then we say out ray cast hit info. If you haven't seen the syntax, by the way, new C# is awesome. You can declare the ray cast hit right in there. You don't have to do it outside. And then if something is hit, we check to see if it's an enemy. If it's an enemy, we call select. So it's just saying, hey, if I click on something, call this method. Okay, so you've got all that. Now you know what it does. So if I click on something, select gets called. And if select is called, we say, hey, does the enemy selection count contain the key of enemy? This is a very cool and important part of dictionaries. This contains key. It allows us to check to see if there's anything in there with the key. Pretty simple, right? It's named really well. So if it does not contain the key, so if it equals false, then I actually add it right here. So there are two ways to add this, by the way. You can add it by setting it just like this with the square brackets equals, or I could alternatively just do this, dot add, and put it just like this with the key and the value. That's kind of what it looks for. I have a habit of doing it with the square brackets in the setting only because if I'm not doing an add, if I'm doing like an add or update, then it just works and I don't have to do the contains key check. I can just do equals that value, and then I don't have to worry about it. So whatever. I'm going to leave it like this, though, because it really works either way. So what we do is we set the value to 1 to count that I've clicked on or selected the thing one time, the first time through. Otherwise, so if it already did contain this key, I just find that value and increment it. So I increment the integer at this key in our dictionary. So it's going to go to 1 the first time, it'll go to 2, and then I have this method called tint enemy if we clicked enough, which just checks the dictionary here by the enemy to see if it's greater than 5. So if I've clicked it more than 5 times, we turn it red. Let's go take a peek at that. So here I've got the project set up, and I have this in a beta version of 2019, so it's a little bit finicky. So I'm just going to do a real quick re-import just to make sure that everything's good. All right, we'll hit play and fix those tricky lights behind me. And we should be able to spawn some enemies. There we go. And as I click on them, so let's click 5 times on this cube. Turns red. If I click on this guy, and 1, 2, 3, 1, 2, 3, bam, 5, and 1, 2 more, turn this guy red. So here I'm just using this dictionary to keep track of how many times I've done something to some object. Now, you might think like, hey, whatever, we could add the click count onto the object. Maybe if the object is really supposed to be keeping track of how many times it was clicked, but maybe you've got another system that wants to keep track of things and you don't want to keep bloating your other objects up, and you just need to keep track of it for something unrelated to the object should know about. And in this case, it's a really easy way to associate some data with some object. So we could do the object key and the number of them that you have, or the state of it, or the condition it's in, how much damage it's taken, anything like that we don't want to necessarily put on the object is a really cool and interesting use. And of course, there are hundreds and hundreds of uses, probably. I don't know. I could probably come up with a dozen at least, but there are probably hundreds out there for dictionaries. So let's go on to one more, the one that I kind of tricked you about that I thought I was going to hit earlier, but I didn't yet. And that's the inventory system. The inventory system's using 2 different data structures here. We've got a stack and a dictionary. Our stack is of type item, and our dictionary is an item or integer key with an item value. And you can probably tell by the name, it's based on slots. So this is saying like, maybe I want to have a slot-based inventory system. And for this example, I want to have 10 slots available. This could be variable. I could have some way to get more slots or change the slot system completely, or even not use slots. But slots is a really good, simple example here. And it works in a lot of games where maybe you just have a bar of slots of things, or you've got, however you display these slots, it doesn't really matter. So let's just say we've got numbered slots here. In this case, maybe they're hotkey slots. How do we use it? How does it work? And how does the dictionary and the stack, what's overflow items, what does it all mean? Well, let's take a peek. So in our constructor here, we just initialize these slots. So what I'm doing here is actually stupid because we don't need that. And I'll show you why. Because I actually made the other code even smarter. So we can delete this, delete that, delete that, delete that, and shrink stuff up. So just remember, when you see stuff on the screen, doesn't necessarily mean it's good. If I put it up, doesn't necessarily mean it's the right thing or somebody else does. Like sometimes people put code up and they forget to delete it. In that case, yeah, that was me. So let's see the cleaner version of it right here. So I've got this add item method, and it takes in an item, and what do? We look at the number of slots available, and we loop from 0 to the number of slots available. Of course, if you're thinking, hey, we could cache the next available slot, sure, we could. We're just doing it simple, though. There are definitely lots of optimizations here, and we're looping over 10 things. It's never going to matter unless this number gets a whole lot bigger. So anyway, we look to see if the dictionary contains the key of the slot number. So right at the beginning, the first time we add something, this dictionary is totally empty. It's going to be false. So we don't even care to check to see if it has an empty item in it. And that's what this is. Does it contain the thing, or does it contain a null thing? Either way, if it's empty or it's null, then I want to set the value there to this item. And that's where I was talking about using the assignment instead of the add. This is exactly the case, because it could be that it just didn't contain it, or that the value was null. In either case, I want to put the item into that slot. And then my code gets a little bit simpler because I don't need an add and a set. I just have this one call. And then we bail out. We say, hey, we added the item, we're good. But what if we ran out of slots? So we've got 10 slots and we're adding item number 11. Oh, nothing ever gets added here. So I've got this overflow item set up, and this is a stack of items. Now a stack is a collection that you can add things onto and then pull things off of. So whenever you add something to a stack, it goes on top. It's just like literally a stack of things. If you stack a bunch of crap on top of each other, you have to take them off from the top. You can't take things off from the middle or the bottom. So as you stack them up, you have to pop them off the top. And it's called a push and pop, but it's really like stacking it up and then taking it off the top. So that's how a stack works, and that's what we're using for this. Because I want to keep putting items on there, but as I take items off, I want to take them from the top. So let's see how that works and how I'm actually using it. And I'm doing it in this delete item method. So I've got a delete item where I take in a slot. It's just the number. So like, hey, I want to delete item 4. First thing I do I have an item in slot 4? If I do, if there's a value there, there's an entry there. Oh, first I also make sure that the item's not null, because if it's null, I don't want to blow up. Let's just make sure that it's actually not a null item and we're not deleting an empty slot. If we're not deleting an empty slot, then we set the item. And what I'm doing here is a little bit weird, and I feel like I should just refactor it to make it a little more easy to read, but instead I'm just going to explain it in detail, because I know a lot of people see the operators here and they get a little confused. So what we're doing is assigning the value for this slot to either this or this. So if the overflow items has any entries, the any is a link statement, so we just do .any. If it has anything, then we're going to assign it the value of whatever the top thing is. We're going to assign it the thing right after the question mark. So if this is true, we assign it this. If this is false, we just assign it null. So the other way I could do this is just like, let's just do it. I want to write it out to make sure that everybody understands it. If you understand this already, sorry. It's just going to be a couple seconds. The other way to write this would be just like that. So you can see it does the same thing, but it's just a lot longer. So I like to write it the shorter way. So hopefully that was helpful. Oh no, I've undone too much. Hopefully that's helpful though, and you kind of understand how these work. But we're filling the item with whatever the thing is on the top of the stack. Now if we wanted to take the oldest item from the overflow, so say I've gone out, I've picked up 5 items with my inventory full. They're all in this overflow stack. And then when I delete items, I'm getting my most recent one. Say I want to change that so that I get my oldest item instead of my most recent item. That is where we just simply switch to a queue. So we change the stack to be a queue, and we change these keywords just a little bit to enqueue and dequeue, and that's it. Now it's going the other way. So now the oldest item that went into my overflow will be the first one that pulls out. So instead of stacking up and up and up and having to pull from the top, I stack up and up and up and I pull from the bottom. It's more like a queue or like a line at an amusement park or a store or anywhere else, or the first person in or the first thing in is the first one out. So that's the difference between a stack and a queue, and one of the many, many use cases for when you'd want to use them. A lot of the time, if you're doing like a pooling system, it doesn't matter at all, right? You could use a stack or a queue or whatever, and it's not going to make a difference. But there are cases where making a choice, or knowing the difference between them can make it so that you can make a choice like this and easily switch back and forth between them relatively quick. Well, yeah, very easily, right? Anyway, I'm going to stop talking about collections for now, but there's a lot more to learn about them, I think. There are a lot of cool extension methods on them. If you haven't used link extension methods, I highly recommend you check out some of the videos and stuff on that, because it makes it very easy to get data and filter data in them. It's important to note, though, that they can be bad for performance. Not the collections, but some of the link statements. So when I do those, they're usually like one-shot things or things that are rare. They're not something that you want to do constantly. You don't want to be doing a 2 dictionary every frame or something like that. But you can do it totally fine in your load, because the hell, it's your load. Doesn't matter, right? Anyway, if this is the kind of stuff you like, again, just remember, please share it. Whatever you do, just share it. Let me know. Drop a comment. And if you have some other ideas for collection stuff to talk about, just let me know too. I'm kind of curious what other stuff people want to hear. I thought that these were kind of the most important ones and the ones that I use most of the time. There are quite a few other ones, but I don't know if anybody cares. Anyway, thanks again. Bye. That's all I got.